Welcome to Haxby Shed. This is an update on my last video where I installed a spindle bearing oil pump to my Harrison 140 lathe. And I did that because I didn't think the spindle bearings were getting enough oil at low speed. And as we finished the video, I just put in this oil, which is too thick, 75W90 oil. We're only 2 days further on, it's got to come out. Nobody's fault, entirely mine. I made a mistake on that. And I'd fitted this small gear pump, which was really struggling to shift that oil. And it's not continuously rated, so it was getting very hot. But I've had a look around for a replacement oil pump, electric oil pump, and it's very difficult to find anything that's continuously rated. Also, they're too big, they're shifting too much fluid, and I've decided the best thing to do is to buy a timer for this and just run it on a short cycle. And then I think it'll be okay if I put in thinner oil. The royal purple oil is drained out. Now that I've drained the royal purple out of the gearbox, I'm going to put in some of this Dexron 2 ATF. It isn't what I would normally choose, but we've got loads of it. So we'll see how well the bearings lubricate with this in and how well the pump performs. It won't stay in for long, it's just a test. Compared to the 75W90, it's like water. The pump seems to be a lot happier with the ATF. Let's test it with the ATF. (120 RPM), nothing splashing. When we used the ISO 68 oil, the oil was just splashing onto that ledge at 250 RPM. With ATF in the gearbox, it's just starting to splash on that ledge at 220 RPM. So it really hasn't made a lot of difference at all. And actually the gearbox is really clunky when I try and change, and the oil's like water. So I'm not going to stay with this whatever happens. I thought we'd just about done with this and just the electrical work to do, but I got hold of the clutch and moved it, and I heard a clunking noise. Can you hear that? I don't think it should be making that noise, so I'm going to have to investigate that. I've just slipped the belts off so that I can spin it more freely. And actually it seems to be spinning just fine, and I can't get any movement on it, but I do get a bit of clunking this way. There's a bit of movement on that pulley, look. I'll have to take this apart, I think, and see what there is. Okay, well, when I disengage the drive so the pulley spins freely, I don't think it should be doing that, you know. Feels like the bearing on that pulley. It's going to be a strip down, I'm afraid. The spring retaining cap comes off with a left-hand thread, and then the first clutch plate comes off. Now this pin needs to come out, and then this and the second plate will come off. To check the bearing, I've just clamped this pulley up on a short 16mm thread shaft. Don't worry that it's off centre. And it seems to be absolutely fine. So this bearing's good. So the problem is that we've got some rattle on the spline on the lathe power input shaft. So I'm going to have to clean that up and Loctite it. Stop the wobble. I've put this pulley back on with Loctite 641. Now I'm not a Loctite expert, but I believe that's one that comes apart more easily for maintenance. So now I can start putting the two clutch plates back in. I used a felt pen to put a blue mark on here and blue marks on the parts that I'm putting back together so I can get them lined up the same. Now the pin needs to go in. Right, I'll just tap that in now. Now the second plate. On this end plate, you can see there's a spline there which is fixed to the plate. But on this side, there's actually a nut which is splined on a thread, and it contacts, this ring here contacts the two sides of this pin. So you've got to be careful when you put it back together not to rotate this internal nut, otherwise you'll put it out of adjustment. If it was set correctly, if not, then you have to adjust this by a couple of splines potentially. Anyway, I've marked it so I know which way on it all goes anyway. There we go, so that should operate correctly. There we are, look. Can you see it moving away from the clutch plates? And it's supposed to be so that you move the lever 1 inch before it starts to bite. The end of the lever, 1 inch. That's all right, I believe. There's the biting point just there. And the lever's moving about 1 inch at the end. Then we put on 12 Belleville washers, 6 of them opposing the other 6. And then we put the end cap on with the spring. Left hand thread. I'll have to do this off camera, I think. This left hand nut then needs to be tightened until the Belleville washers are fully compressed. And of course then the lever won't move. And then you turn this clockwise. It says in the manual 1/3 of a turn, but it's going to need a little bit more than that, I think. A bit more. There we are. So now that spins freely, and the brake is on the shaft. Let it go, and it all spins just as it should. So I'll leave that to go off now and get on with some electrical work. But not forgetting this Allen grub screw needed to lock this nut on the end. There we are. The power supply will go behind this panel, which I can remove with 4 Allen screws. None of this contactor gear is in use. This big rotary switch is for the reverse. And then you can see my inverter just down there, tucked in the bottom. But I've also got a 13 amp socket strip, so I'll just plug the power supply into that. And there's a bit of conduit that runs down from this gear casing and exits in here, and I'll just run my cables down through that if I've got enough room. Managed to get the wire through the tube in the end. A bit of fiddling. The pump is now installed. You can see the pipe which comes from the headstock gearbox. This pipe, which runs up here, feeds the spindle bearings and other bearings through pipes which are in this lid. I've got to wait a while for the Loctite that I put in here to go off, and also I've got to wait for a timer to arrive, which I've ordered from eBay. And the idea of the timer is, because this pump's not continuously rated, the timer will just run on, off, activated by a button. So I'll just use the pump when I need it. Now the way this is designed, if the pump fails, I just take it out of circuit, I can loop these two together these two pipes. If I want to take the whole thing away, I just basically put the lathe back to what it was. So nothing's spoilt in that sense. So now I need to wait for this timer to arrive. I'm going to make a modification to the aluminium lid. If you look at this plug, this magnetic plug, you can see that it goes down towards the hole that feeds the spindle bearings, but I don't think it goes down far enough. I made that plug position identical in depth to where it sits on the aluminium lid. Having observed the oil flowing by, it creeps under there through that quite large gap, and I'm not sure at all that magnetic pieces would be picked up by that magnet. So I'm going to bore out the hole in the lid a bit, probably about another 4 or 5 millimeters, to take that lower. Now you can see it's slightly off to the right, not perfectly aligned with the hole, but that was just my misdrilling. On the aluminium lid, it does align perfectly above that hole. I've set the lid up on my pillar drill and lined it up and clamped it down, and I'm going to start by boring out 4 millimeters depth with this 15 millimeter end mill. This is 19 millimeters, but I don't have a 19 millimeter or 3/4 end mill. So I'm going to finish it off by using this boring bar as a fly cutter, which is what I did when I made the transparent lead. Now it'll be tougher for it on aluminium, but hopefully it'll be okay. Well, that went smoothly enough. I'm less confident about the fly cutter idea. Fingers crossed on that. So that pocket is now 4 millimeters deeper. Just clean it out, 1/4 BSP. That magnetic plug stuck down about 7 millimeters below the lower edge of the lid, and now it sticks down about 11, which is what I wanted. And there's plenty of thread on that boss to take that plug, and there's plenty of meat around it too. Good morning. Now I can put the oil in and I can put the belts back on. But I want to say that I have had some excellent comments to help me. I always get excellent comments on this channel, actually. Thank you very much. One comment was, why couldn't I put a spinner on one of the gears in the gearbox? And when I saw that, I thought, gosh, what a simple idea. And I looked at it. The trouble is, this big gear, which is about the only one that picks up from the gearbox, slides across. So there really isn't anywhere you could put a spinner, because it always, in some position, would interfere with other gears or with the casting. Another suggestion was, could I use a peristaltic pump? Now, I didn't know what that was, so I had to look it up. Now, if you have ever seen a pump which is used for a blood transfusion, you'd know straight away what it was, so I'll show you a picture. Peristaltic pump, and it's where a roller will push the fluid along through a tube. Now this was what I found on eBay. I didn't order this. £12.50, delivery 6th of April to the 12th of June, and it would pump 150 millilitres a minute. So that was quite appealing, but it was the delivery date was too far away. So I found a different one, which I did order, which was £8.40, 80 millilitres per minute, and they could deliver it by the 15th of March. Now, I tend to measure things in cost against a coffee. So a coffee here is about £2.75. So if it's worth one coffee, I just order it. 2 coffees, probably. 3 coffees, that's starting to get expensive and needs a bit of thought. 4 coffees, that's a strategic purchase. And I think 4 coffees are okay if it's just a one-off. But if you're ordering lots of bits like this, £6, £8 a time, you soon run up quite a bit of money. But the Peristaltic Pump seemed to be such a good prospect, I wanted to give it a try. And the thing about it is, the fluid stays within that tube, so you haven't got any problem with seals or anything like that. And the other thing is, it's probably continuously rated. So the one that I bought, this one, it's actually for dosing fish tanks, but it's worth a try. Now, I'll finish this video when the timer comes, and I'll try the timer with this pump. And then sometime in the future, I'll add a bit onto another video explaining how we got on with the Peristaltic Pump. No clunking. Nice and smooth now. So we're back to the original ISO 68. I've completely given up with the thin oil society. We put the ATF in, it really didn't make any difference to getting oil onto this front ledge. And the gearbox sounded pretty rough, I thought. So let's go for the oil that was specified. Despite what I thought, this oil is not thick. It runs very freely. It's about 5 degrees here. If I wanted to try something thinner at this stage, I would go for ISO 32. So just a reminder, the tubes are here, here, and it comes up here. It hasn't been bled yet. Difficult to keep the reflection off the lid and focus, but I think you can see that. The oil gets onto the ledge at 220 RPM in that position and 240 RPM in that position. With the pump just tucked in there like that, I think that's pretty good. I felt a bit negative about it after the first video. I thought really it hadn't turned out all that well, but now I'm feeling much more positive about it. I think it works pretty well altogether, really. The timer has arrived. I don't know how it is where you live, but since the pandemic, deliveries just seem to get quicker and quicker. Sometimes I order things on an evening and they arrive the next morning. And I think before long things will start arriving before I order them. I'm going to have to be careful what I think about. It's a bit untidy, but it's wired up now, so I'll turn the power on. And the red light comes on to say it's got power. And then if I touch these two wires together, it should run. There you are, the green lights come on now. And that'll keep running until I press again. Now, depending on the mode, it'll either run for a period and then stop, and that's it, or it'll run for a period, stop for a period, run for a period, stop for a period, forever, until I touch the wires again. So I just need to check how it's set up now. I'm just putting this shot in for one of our daughters who bought me this stand for soldering, and she got it from the supermarket, picked it up in the trolley, thought of me. So I've put it in for her to see, but it doesn't increase the chances of her watching this video, to be honest. Right, that's it, done, it works. The on time is set to 30 seconds, the off time is set to 15 seconds. I've connected it to my green button here, which is a normally open button. It's not in use because none of this is in use here. And in case you're concerned, these other connections over here on the rotary switch, they're all low voltage because everything in there is low voltage. Now I've got the inverter, all the control lines are low voltage. So I'll push all that in, screw it up, and then just take one final look at it. Right, I think we now have an operational solution. When I turn on the power to the lathe, the power will be turned on to the timer. If I press the green button, the pump will run for 30 seconds, stop, wait for 15 minutes, run for 30 seconds and so on. I can cancel that by pressing the green button again. So here goes. I'll keep it as it is for a while. I've got that other pump on order. I'll keep the transparent lid so that if and when I fit the other pump, I can see how that operates, and then hopefully I'll make a decision and then go back to my genuine aluminium lid and we can move on. So, I hope that was useful to you. Thank you for watching. Hacks be shared.